This is a variation of a challenge question I gave you last class, but we'll take a look at how we can break this down. Just as before, if you took the time to look at this image, you will realize that you don't have enough information to solve for x. Right? Take a look. Let me take that piece of paper just to mask this. If you were to just look at that smaller right angle triangle, I have an angle, I have an unknown side. There's nothing else to work with, so you can't use SOHCAHTOA. Let's talk about the larger triangle. Let's erase this for just a quick second. If we look at the larger triangle, I have one angle, an unknown side, and I have a piece which doesn't help me. In other words, SOHCAHTOA for either triangle is not going to work. However, at this point in time, you may want to consider introducing your own variable. So, true to what Noah was yelling at before, I'm going to introduce the letter N. Just N for number. Okay? Question, Olivia?
If you have two angles, could that give you cycling? Like,
I think you can answer that question already. Think about it. Think deeply about it.
you need to think deeper. I'm not gonna get it.
Well,
Just give me a second.
thinking deeper means you have to dig. Get it?
You should think deeper, plan deeper.
Never mind. Let's put it this way. By introducing a variable, I am going to try to use that variable to, well, help me for both triangles. Take a look. How about I call this triangle A, B, C, and I'll introduce the letter D here. So for triangle A, B, C, we have some kind of equation that's going to keep the x in there, and of course use that 100 as part of my as part of the ratio. Think about it. What ratio would make sense in this situation?
For like the whole triangle itself.
For the larger triangle, I'm looking at this side, and I'm going to use the base. SOHCAHTOA, tangent. Right on. Tangent of 23 degrees is going to equal opposite over adjacent. Okay? And on the flip side, if you want, how about a line? For triangle ADC, I will have tangent of 27 degrees, which equals a ratio of opposite over adjacent. With me? So just like before, do you see the similarities of what I have done? Angle, opposite, and adjacent. Do you see the difference? 27 versus 23, and the base is 100% versus n. So there's clearly similarities and differences because, well, two triangles are obviously different. Yes?
How do we know not to use the method where it's like n right there would equal 100 minus n? You know that one that you showed us last time?
Yeah,
The
but
minus.
that's because if the whole thing was 100, so if you were to split it in half, it would equal 100.
So more than thinking about the actual step, if you think about it, if you really sort of consider the approach that you just mentioned, does it make sense logically? Right? We're not taking away from 100. We're putting something onto it to cover the entire length. Right? So just think a little deeper about it, and you'd be like, oh, that doesn't make sense. I'll go the other direction. And that's growth right there. Keep it up. Okay? We have an equation with ratios. We're trying to get the x's all alone because that's the whole point. Let's do this one, is easier. If I want to get x all alone, both sides ought to be multiplied by the denominator. We have n times tan 27 is equal to x. And in the same breath, follow along with me. How to get x all alone? Yeah?
Plus n.
That means, yeah. Remember, this is a number. I don't know what that number is, but you have to just treat it like a regular number. Just like how this was n and I multiply both sides by n, this is some number, I'm going to multiply both sides by that number. So if I do so, this becomes 100 plus n tan 23 equals x.
Equals.
And look what you've done. You have two different equations isolating for x, and both x's represent the same length. And because they are two different equations talking about the same thing, we can actually bring this together and say 100 plus n multiplied by tan 23, and this is around the time you want to take out a calculator to help me out.
0.42.
Okay, versus n times tan 27. So this was, sorry?
It's 0.4244.
Okay, 0.4244. That's going to be multiplying in based on distributive property.
Wait, we should do. It's 0.4244. But should we keep those fours at the end or just do?
Try to keep as much as you can until the very end. I highly recommend that, especially in the context of science. Significant digits become very important. So until you have a lesson on that, I recommend you just try to keep as much as possible. It's a good habit to have. And it's tan 27?
Is 0.509.
509.
Yeah.
One more.
Okay.
Thank you. There it is.
No.
And all of a sudden, we have an equation that you can solve with algebra. Just isolate for n. You're trying to group the like terms together, get n all alone. How about I do this? I will leave 42.44 here, subtract both sides by 0.4244n. 0.
Oh, the reason you do they equal each other is because they both equal x.
They're
right?
both representing the same length. Yes. Keep chewing on it. Yep. Do it.
Yeah, I was just wondering, since you have like how would the one line be the same length? Because if you have, let's say you're using the 23 and the 100, how would let's say the AB line be the same length if it was the whole like BC line?
Well, it wouldn't, but we're not talking about the line AB. We're talking about the height. The two triangles share the same height.
Yeah.
So this one and that one. Yep.
How did you get the 42.44 there? Like on the bottom there?
Tan 23 represents a ratio.
Like on the very bottom, like what happened? Like,
I left 42.44. I brought 0.4244 to the other side. Do you see how the term with n has?
no, that's why I'm confused because like where that comes from. But now.
Okay, let's move on. Figuring out this the final step. If that is the case, let's get n all alone by dividing both sides. Okay.
No, I thought they were going out.
They are.
Yeah, they are. I thought they said.
It's 498.707. So what would you round that to?
That was like the whole lot.
That's what it says on my
So
chart.
400 plus 2.
498.707. But what would you round that to?
7?
707, not 9.
0707. Okay.
No. 498.707.
498.707.
Yeah, not this. But don't you say the round is at the end? So would that be 499? Or no? Or is just around that last decimal?
No, we're not done yet because we're looking for x, right?
Okay.
So now that we have this unknown length, you can choose whichever triangle you want because either one we have a base. So how about we just use a simple one? I'm going to bring it into tan 27 is equal to x divided by 498.707. So x is going to be 498.707 multiplied by tan 27, which is some number.
You see that number for M is right? That number for M is right? It seems like really big.
It does seem a little bit big. I don't see anything wrong that we've done here. We have tan 23 is opposite over adjacent, which should make sense. And then we have this multiplying with each other, distributive property, and so that should become right.
That's right.
Mm-hmm. I don't see anything wrong with it. 23, 4, 7. As long as you're doing this one right for me, because right now, again, I don't have my calculator with me. Could everyone check? Tan 23 and tan 27?
10, 23 is 40, 0.42.
Okay.
Tan 27 is 0.509.
Okay. So we're doing it right. So then go all the way to the end. Tan 27 is equal to x over that number, this large 498 number. What is x equal to?
Wait, when the x is on top
Yeah.
of the 498, can you just multiply each side by 498?
Yes, the purpose is to get rid of the denominator.
Yeah, but
which
when
is a
x is
division.
on the bottom, you have to cross multiply them.
Yes, again, it's the same thing. If x is on the bottom, you multiply both sides by the denominator to get rid of it.
Okay.
It should work out. Someone do this for me?
It is 254.13.
Yeah. Or meters or whatever unit that minus could be. Okay, therefore, the height, in this case, the x value, is 254.103, so about 254 was it? Okay. Just another example of these challenge questions. Yes.
I don't really understand how you can just like combine the two equations. But how does that? How do you just do it?
Well, again, as opposed to thinking about it mathematically, think about it logically. We looked at this larger triangle, and we have an equation that tries to explain what the value of x is. I also did the same calculations using the smaller triangle, where we're talking about the same side, aren't we? We're talking about the same side.
Yeah.
So whether I use a large triangle to talk about x or the smaller triangle to talk about x, both values should be the same. Which means the equation I get on this left side and the equation I get on the right side should also be the same. Like if A equals B, but A equals C, B and C should be the same. It's that same idea, right? If this equals that, but this equals that, these two should be the same. And that's why I put a big equal sign right next to each other.
But don't you say the round is at the end, so would that be 499? Or no? Or is just around that last decimal?
No, we're not done yet because we're looking for x, right?
Okay.
So now that we have this unknown length, you can choose whichever triangle you want because either one we have a base. So how about we just use a simple one? I'm going to bring it into tan 27 is equal to x divided by 498.707. So x is going to be 498.707 multiplied by tan 27, which is some number.
You see that number for n is right? That number for n is right? It seems like really big.
It does seem a little bit big. I don't see anything wrong that we've done here. We have 1023 is opposite over adjacent, which should make sense. And then we have this multiplying with each other, distributive property, and so that should become right.
That's right.
I don't see anything wrong with it. 23, 4, 7. As long as you're doing this one right for me, because right now, again, I don't have my calculator with me. Could everyone check tan 23 and tan 27?
0.42.
Okay?
And tan 27 is 0.509.
Okay. So we're doing it right. So then go all the way to the end. Tan 27 is equal to x over that number, this large 498 number. What is x equal to?
Wait, when the x is on top
Yeah.
of the 498, can you just multiply each side by 498?
Yes, the purpose is to get rid of the
Yeah,
denominator.
yeah. But
which
when
is a
x is
division.
on the bottom, we need to cross multiply them.
Yes, again, it's the same thing. If x is on the bottom, you multiply both sides by the denominator to get rid of it.
Okay.
It should work out. Someone do this for me?
It is 254.103.
Yeah. Or meters or whatever unit I might have given you. Okay, therefore, the height, in this case, the x value, is 254.103, so about 254 was it? Okay. Just another example of these challenge questions. Yes.
I don't really understand how you can just like combine the two equations. But how does that? How do you just do it?
Well, again, as opposed to thinking about it mathematically, thinking about it logically, we looked at this larger triangle and we have an equation that tries to explain what the value of x is. I also did the same calculations using the smaller triangle, where we're talking about the same side, aren't we? We're talking about the same side.
Yeah.
So whether I use a large triangle to talk about x or the smaller triangle to talk about x, both values should be the same. Which means the equation I get on this left side and the equation I get on the right side should also be the same. Like if A equals B, but A equals C, B and C should be, it's that same idea, right? If this equals that, but this equals that, these two should be the same. And that's why I put a big equal sign right next to each other.
Can you do another question?
Similar to this
are
one?
we,
Yeah.
Are we combining those two like as if it was?
They're one and the same.
They become one equation. Those two.
Yes, this equals that.
So shouldn't there be like an x equals somewhere? Where does x go?
I essentially made it disappear. That's why I call it
I
substitution.
see, because the 100 plus 110 equals x, and
So if this is x, but this is x, I essentially took this and
wrote it
substituted it.
different ways.
Yes. That's why I say there was a substitution involved, right?